Alright, we're on 6.3 already. Holy moly, cruising. Alright, and 6.3 is going to be tests for parallelograms. Okay. Alright, so test for parallelograms. We're going to start each of these statements. These are 4 theorems that we're going to write down. So if a quadrilateral has ... and then we're going to do 4 examples here. It's kind of like that comedian that's like, you might be a redneck if, and then it goes on to like say what it is, and it's funny. Don't know what I'm talking about, ignore that. Alright, so if a quadrilateral has, our first case scenario is both pairs of opposite sides are congruent. So I'm going to draw that out. Alright, I see that's not a very good drawing, but I'm going to change it. So I'm going to say that this side here is congruent to this side. So those are opposite and they're congruent, and I can see that with those tick marks. And then these ones are congruent. So if I see that, I know it, either it's marked with numbers and I can see they match, or I can see with the tick marks that they match. Then it's a parallelogram. Okay, that's one theorem. Our next theorem says if both pairs of opposite angles are congruent, so now I'm doing angles. Remember, that's our corners. So we use arcs for those. Is congruent to that one. So they're opposite. And then I do my other opposite, but they're not the same. So I can use 2 arcs to show that they're different. So either I might see numbers there showing that that works, or I might see those arcs. And if I see that, then it's a parallelogram. Okay, we have 2 more theorems to do with this one. So the next one is if we see a quadrilateral, a 4-sided shape, and we know that the diagonals bisect each other. Okay, so remember diagonals, it looks like if we have a parallelogram, kind of a long, skinnier one here. Diagonals, remember, go across. So they connect corner to corner. This isn't a very good drawing, but that's okay. Because yours is probably professional, but mine's not. Alright, so remember, bisect means it cuts it in the middle. So I see that this side here is congruent to this side. So that is our midpoint. Right, and same thing as I follow this one, it's not necessarily that these are all 4 the same, it's that these match. So this side matches this side. Again, I have 2 tick marks there. Then it's a parallelogram. How exciting. All right, last one. And this one's a little different. This one, so far, these have all kind of gone with our theorems that we've done. This one, I think, kind of goes with theorem number 1 from that foldable. This one's like theorem number 2. And this one, if we look back at our foldable, is like theorem number 5. Okay. But this one's a little different. It's not on that foldable. Okay. And what this one says is that if I have one pair of opposite sides that is both parallel and congruent. Okay, so if I draw that out, I only need to look at one. Ooh. It's really bad parallelogram. Let me do that. Okay. There we go. That's better. Okay, so I'm looking at opposite sides. So it could either be these two or it could be these two. Okay, and first I need to know that they are parallel. So as I look at parallel, parallel means that they are running in the same direction. And we usually see that with those arrows. Remember, arrow, arrow. And that shows they're running in the same direction. They'll never touch. And it has to be congruent. And congruent means that they are the same. So this is the same as this. So we see the tick marks and we see that parallel line. Then it's a parallelogram. Okay, so that's one that's a little different. It could be these two sides or those two sides. Doesn't matter which side, but they have to be opposite of each other. All right, so for your practice today, it's going to be like one part of it is going to be with that foldable, looking at those theorems. And then the other part is going to say, okay, do you have one of these 4 scenarios? Yes or no. If you do, then it's a parallelogram. If you don't have enough information. And that's it.